Okay, so today we're going to just finish up vectors, and then we're going to do wrap up some more of our chain link conversion, and then we're going to go to math, and we're going to do difference of squares and greatest common factor, which you should have had in Algebra 1 for sure. So we're just covering some Algebra 1, but as we get going in math, the Algebra 1 will be harder than what you had in Algebra 1. And then we'll do some other things from pre-calc. Okay, so first was your homework, was 10 minus 4, negative 12, 10. You should have gotten this. So if you add them mathematically, you get negative 2, negative 14. And that's what it should look like. So you draw your first vector, 10 minus 4, go over 10, down 4. You draw your second vector, negative 12, 10. So you go left, negative 12, down, negative 10. And then you add these together, so you get negative 2 for negative 14, and it should look like that, over negative 2, down negative 14. Okay? Then you had 3 conversions. The first one was 3 times 10 to the minus 3 kilometers per second into miles per hour. So this time we're changing both distance and time. Naya, did you get it?
I got 9.31 miles per hour.
Okay, I have 6.71. So we have 3 times 10 to the minus 3 kilometers per hour times 1 mile is 1.61 kilometers times 3,600 seconds is 1 hour. Okay, so miles into kilometers, and you get rid of kilometers, and then seconds into hours, 3,600 seconds in an hour. Now you could have gone seconds to minutes and minutes to hours. The next one, 70 kilometers per hour into meters per second. Kylie, do you have that one?
19.44.
Good. 70 kilometers per hour times 1,000 meters in a kilometer. And then again, we're getting rid of hours and putting it in seconds. 1 hour is 3,600 seconds. The last one was 85 miles per hour. And you're putting that into meters per second. Anybody? $37.7. 85 miles per hour, 1.61 kilometers in a mile, 1,000 meters in a kilometer, 1 hour and 3,600 seconds. If you did feet, if you went miles to feet, you should have gotten a similar answer. 5,280 feet in a mile, and then 12 inches in a foot, and then 2.54 centimeters in an inch, like that. Okay. Green Country Bus is late, huh?
Yeah. It's been a little later than usual.
Okay. All right. Are there any questions? So maybe these things where you have the 2 dimensions are still a little rusty of trying when we are converting both distance and time. Let's do another one. 20 miles per hour in millimeters per second. That's what we just went over. Okay, so you got it into meters. Okay, meters supposed to put it in miles per hour, you put it in meters per second.
Oh, I'm sorry.
That's okay. Kilometers per hour, meters per second. Okay, so then we start with 70. You have maybe put your 70 in there. There's 1,000 meters in a kilometer. You had to put it in miles, so 1.61. You had to use this one time you did it. So you start with 85 miles per hour, and then you would go 1 mile. That's right. That part was right. So we can multiply it by the 85. And did you see the vector? The vector homework looked like this. We have 10 minus 4. Okay, so 10 over 10 down 4. And then, so we go over 10 down 4. I think you got that first one. And then we go negative 12, negative 10. So we go left, negative 12 down, negative 10. And then we connect the end of this, from the beginning of the first one to the end of the second one. We'll do some more of that today. Okay, so first you're putting miles into kilometers. So you have 20 miles per hour, and then you have 1.61 kilometers in a mile. That's the easiest way to do it. That's easier. You could do the feet, and in the end, put centimeters into millimeters with 10 millimeters in a centimeter, and go from miles to feet to inches. You don't have to do it this way. It's a little bit easier to do it this way. As long as you do it correctly, you'll get the right answer in the end. So I'm going to change it one time. 20 miles per hour, so we'll just go miles to kilometers. 1.61 kilometers a mile. Change hours to seconds. Go down here. So we have 1 hour, 3600 seconds. Okay, let's go through it. Okay, so will you write down your step by step with all the details? 20 miles per hour. Okay, there's different ways you can do this. Either way, this is what you should end up with. Okay, this is the way a lot of you did it. 20 miles per hour, 5,280 feet in a mile. We've canceled out miles. 12 inches or 1 foot, we've canceled out feet. 2.54 centimeters in an inch, we've canceled out inches. So you should write it out so that you can see what you're canceling out. 2.54 centimeters, and then 1 centimeter is 10 millimeters. And then in the end, we've canceled out hours. The faster way was 20 miles per hour, 1.61 kilometers in a mile, so we've canceled out miles. Now I went straight to millimeters. You could have gone from kilometers to meters, meters to millimeters, but I went straight. We changed the decimal point 6 times. So I know that's going to be 10 to the 6th power. 10 to the 6 millimeters in 1 kilometer times 1 hour is 3,600 seconds. You can do it either way, but you should understand the process and you should write that out where you're, it's good to get the right answer, but you also want to show your process. As problems get more complicated, what you want to be able to do is to make sure and check that you didn't flip something like put divide instead of multiply. With this technique, you keep it straight. Okay? Let's put 9,000 micrometers per minute into feet per second. Okay, so you know how to put minutes into seconds. You also want to put micrometers into feet. So think of what conversion we use to get from the British to the metric. Let's write it down again. So UM per minute. Okay, now we want to centimeters. How many times do you change this from here? This is from this form. So you want to become So you look at how many times you change the decimal point from micrometers to centimeters. Go from -6 to -2. And then you put 10 to that power. So what you want to do is put it in centimeters. So go from micrometers to centimeters, centimeters to inches. This is like a big U, not an M. It's a micro. I know it looks like an M. What should we do? Like instead of an M, like this one. Okay, so 10 to the 4, that should be micrometers in a centimeter. Now, you want to have the centimeters, units, and pounds. Centimeters has to be over 10 to 4 micrometers. So 10 to the 4 needs to be down here, 10 to the 4 micrometers in a centimeter. And then once you get it in feet, you're done. You don't need to put it in yards, you just need to put, after that you put minutes into seconds. So put micrometers into centimeters, 10 to the 4th micrometers in a centimeter, not 10 to the 4th centimeters in a micrometer. Centimeters into inches, inches into feet. Now you have to simplify that. So it's kind of painful. Okay, so put 60 seconds in it. Good. Now you're done. Okay, now we got to know this divided by that, times that. So put it in here. Let's go from micrometers to so. How many seconds in a minute? Okay, let's go over it. Did you get it? So we have, you should get a really small number, 9,000 micrometers in a minute times 10 to the 4th micrometers in a centimeter times 2.54 centimeters in an inch times 12 inches in 1 foot times 60 seconds in a minute. So it's 9,000 divided by 10 to the 4th, divided by 2.4, divided by 12, divided by 60. Now you'd have to put everything in parentheses if you're dividing this in your calculator. Unless your calculator does that for you, when you go like this, you have to put parentheses. 10 to the 4th times 2.54 times 12 times 60, close parentheses. The other way we could have done it is 10 to the minus 4 centimeters in a micrometer. There are 10 to the 4th micrometers in a centimeter, and we can flip that and say 10 to the minus 4 centimeters in a micrometer. Just put it in your calculator, make sure you know how to get it. Did anybody get it? Nobody? I thought you were. Change time, so it's the numerator. Let's see if we can enter this into So Everybody got it? Okay, you have to put parentheses there. Parentheses. Now do 10 to the fourth. Or like that. Did you get it? Okay, good. Okay. I hope you're getting the idea. That one I think maybe you found difficult because of the 10 to the fourth micrometers in a centimeter or something like that. Okay, we're going to go to math. Oh wait, we have to finish vectors. Okay, so yesterday we started vectors, but we didn't have much time. Did we do this one, 8008? I think we did. Did we add 8008? No? Okay, let's do it. This one, so we go from the end of the first one, we draw this one, so now draw 0 by 8, so x is 0, y is 0, so remember how the vectors are approached, this is your x, this is your y. Okay, so we just draw 0. Does everyone have graph paper? So draw the first one, 0, 8. These are 11. You can just include 2, 4, 6, 8. Okay, so go to 8. That's your first one. Now we go 0, 8. So we go up 8 over 0. Okay, now you draw the end of this one, so it's going to be here. And then you connect the end of the first and the end of the second. So we draw the first one, 8, 0. We draw the second one, 0, 8. Okay, this is our x, this is our y. The way we add vectors, we draw the first one, then we draw the second one from the end of the first one, 0, 8. And then we connect the beginning of the first one to the end of the second one, which is 8, 8. And in this case, you can tell what it's supposed to look like by adding the numbers. When we add the numbers, we get 8, 8, and this is 8, 8. So it should look like what we added. Okay? So you always get a triangle. It doesn't have to be a right triangle, but you should always have a triangle on your paper where they're all connected. Now, I just demonstrate here. Let's say Well, let's just skip that for now and have you do another one. Let's have you do -7 minus 3 minus 5 minus 4. Let's see you add that. So the first vector you're going to draw is -7, -3. That goes into the third quadrant. So let's go to 4, -2, -4, -6, and then let's go down -2, -4. That's multiplication. So let's go -3. Okay, so -2, -4, -6, -8. So now we're going down. So you draw your Cartesian coordinate. We're working in the third quadrant. Then you draw -7, -3, and from the end of that, you're drawing the next one. Okay, so let's go down -2, -4, -6, -8. I'm going to do this one. You don't have to do that.
Yeah.
Okay, now -7, -3, so we go left -7 down -3. Okay, so left -7 down -3. Okay. Now, that's right. Now connect this to that. Second starts at the end of this down to -5, -4. So from the end of the first one, you go -5, -4. Okay, so now from here. Now go -5, -4. Please increase that. So then you're going left 5, down 4. So then we go from here down -5, -4. Left -5, down -4. So we go 5 to the left and down -4. So what you have should look like the sum of this, which is -12, -7. Okay, then you connect the beginning of the first to the end of the second. Okay, so you got that. Now -4 is that one. Okay, so then what you have is this. That's the sum. Okay, so what we have, we go left -5, -3. Oh, sorry, left -7, -3. And then down -5, -4. And then we connect the beginning of the first to the end of the second, and we get this -12, -7. Okay, let's do the next one, and let's do it on graph paper. 6, 8, -1, -7. Draw your coordinate. Just give yourself increments of 2. So your x is 6, your y is 8. Okay, so let's go. Let's just use, let's just do 2, 4, 6, 8. Okay, so let's go over 6, up 8. After that, you go left -1 and down 7. Okay, now we're going down 1 and left 7 from here. Down 1 and left 7. Okay, great. Now you're going down 1 and left 7. So what you have in the end should look like 5, 1. When you connect the origin to what you have, it should look like 5, 1. You just went down 1 like this, and then left 7. So you just went left 1, down 7. You're going left 1 and down 7. Go down 7. So we went over 6, 8. We went down -1, -7, like this. You're going left 1, down 7, and then this is the resultant sum. This is V1, this is V2, this is the sum V3. Okay? So you draw the first one, you draw the second one from the end of the first one, and then you connect the beginning of the first to the end of the second, and that is your vector sum. We'll do one last one. -3 -5, 2, -6. This one we have smaller numbers. So let's just use these as okay, so let's go. The first one is -3 -2. Okay, going left 3. -3 -5. And then from the end of -3 -5, which points into the third quadrant, you draw 2 -6. So -3 -5. Now you're going right 2 and down 6 from the end of that one. Good. So you go right 2. Good. Right. I think you're getting it. So what you have should look like -1 -11 when you're done. After you connect the beginning of the first to the end of the second, it should look like -1 -11. Does it look like that? So -3 -5 points into the third quadrant. It is left 3, down 5. +2 -6, you're pointing into the fourth quadrant. So it should look like this. Okay, -1 was -3 -5, and then we had right 2, down 6. So our final should look like -1 -11. Is that what you had? Okay, good. Let me just give you some homework. We'll start with something simple. Uh, 3, 4, 7, 5. Okay, those are both in the first quadrant. So you should know your quadrants well. Number 2, we're going to do multiple quadrants. So I want to go -6, 3. Which quadrant is that? It's the second. -6, 3 points into the second quadrant. And then we're going to add to that 4 -5. Okay, now you add these together too mathematically, and so what you get should look like that. Now something can point into the third or fourth quadrant, but it's actually not in that quadrant because we left originally. Number 3, -7, -4. Which quadrant is that? Third. Okay, they're both negative. And then I'm going to do a -3 +6. Okay, so add those together first, and what you get should look like that. Let me give you one more. +10. Okay? Use the graph paper I gave you. If you need more graph paper, there's a ton of graph paper back there. Did you write it all down? Okay, now we're going to talk about some things in pre-calc. We're basically done with the math behind the physics. So the only thing left for us to do now is physics. So we will be starting that probably tomorrow. We will start chapter 2, which is the actual physics. So to do the math behind the physics, we're doing a little bit of this, a little bit of that, and a little bit of something else. When we actually start the physics, we just keep moving, doing similar things. So you might find it in some ways easier to follow. Let's start with difference of squares. Difference of squares is a basic algebra 1 thing that you should have had. I'm sure all of you had. It's just the most fundamental basic thing in algebra 1. Okay, so you have got, comes up all the time, x squared minus y squared is equal to x minus y times x plus y. Okay, so write that down. All you do is take the square root of x and the square root of y, and you plug them into the equation. Of course, you have to know what the square root of x and the square root of y are. Okay, so let's go through the first one. So you take the square root of this one, the square root of that one. So we take the square root, this one is x squared minus 16. The square root of x is x, the square root of 16 is 4. We plug it into the equation. X minus 4 times x plus 4. Everybody understand? It was real basic stuff. Here's the next one, x squared minus 25. You take the square root of x, the square root of 25, which is 5. You plug it into the equation. X minus 5 times x plus 5. So all you're doing is getting the square root of the number and plugging it into the equation. One is plus, the other's minus. Now this textbook isn't going to give such simple things all the time. Your high school textbook might have always made it simple, I don't know. But this is technically a college textbook, so it's going to, the square roots get a little more complicated. Okay, so let's see you do this one. Z squared minus 9, that's a simple one. You take the square root of z, you take the square root of 9, and you plug it into the equation. Okay, so we have z minus 3 times z plus 3. All right? Now we're going to go to the next one. So the square root of 9 was 3. 4y squared minus 36. Okay, now I think you know how to take the square root of 36 and the square root of y squared. When you have a constant and a variable, you take the square root of the constant and the square root of the variable. Okay, so the square root of 4 is 2. The square root of y squared is y. We get 2y minus 6, 2y plus 6. Okay. Let's go to the next one. 25x squared minus 4. This is similar to the last one. We're taking the square root of 25, the square root of x squared, the square root of 4. Oh, I meant to do minus 49. Let's do this one also. So now let's move on to the next one. 25x squared minus 49y squared. For the one that I just had, you would have had 5x minus 2 and 5x plus 2. Okay, that was the answer to the last one. But now we're doing 25x squared minus 49y squared. Okay, so the square root of 25 is 5, square root of 49 is 7, square root of x is x, square root of y, x squared is x, square root of y squared is y. So we get 5x minus 7y times 5x plus 7y. Okay, it's a simple idea, right? It's a simple equation. How about this one? 64x to the 6 minus 100. The square root of x to the 6, what times itself gives you x to the 6. Remember, we add those exponents. What times itself gives you x to the 6? And you? X to the third. X to the third times x to the third is x to the 6. So we have 8x cubed minus 10 times 8x cubed plus 10. All right? Not too hard. You're just taking the square root and plugging it in. 81y to the 4th minus 16 z to the 10th. So remember, when we add exponents, x to the a times x to the b is equal to x to the a plus b. That's why we got x to the 6 for x to the third for our square root of x to the 6. So you're taking the square root of 81, the square root of y to the 4th, the square root of 16, and the square root of z to the 10th. Okay, so the square root of 81 is 9. Square root of y to the 4th is going to be y squared. Square root of 16 is 4. What's the square root of z to the 10th? Anyone? Z to the 5th. Because z to the 5th times z to the 5th gives you z to the 10th. So we have 9y squared minus 4z to the 5th times 9y squared plus 4z to the 5th. Okay? All right. Here's a harder one. X minus y quantity squared minus 4y squared. See if you can figure out that one. It is a difference of squares. So take the square root of the first and the square root of the second. And then in the end, you're going to have to combine like terms. What's the square root of x minus y quantity squared? X minus y. So that's the first thing that goes in your equation. Now you know the square root of 4y squared. So you take the square root of the first one, the square root of the second one, and you do the same thing. You add and subtract them. And in this case, you combine like terms. Okay, no calculators, please. Calculators are for physics class unless we're doing graphs or unless it's some unusual situation. Did anyone finish? Okay, so the square root of x minus y squared is x minus y. The square root of 4y squared is 2y. So you have the first x minus y plus the second 2y. This time I did plus and then minus. And then you have x minus y minus 2y. Okay, we're just plugging it into the equation. If I did it in the same order as I did in the past, I would have done minus here and plus there. We'll just do it that way so I have the same order as I did. Okay, so we have x minus y minus 2y and x minus y plus 2y. And then you combine like terms. Jaden, do you have it?
X minus 3y times x plus 1.
Okay. Do you understand? So we get x plus y times x minus 3y. It would actually be switched the other way because I just switched my signs. This is x minus 3y. And this is x plus y. Okay, now let's do another one. Nine z to the fourth minus 7. Show me if you have it done. What do you put in for square root of 7? Right, just put in square root 7. So you have 3z squared. Now, square root of 7 can also be written 7 to the 1/2 power. We'll talk about that more in the future, but you could put radical 7 times 3z squared plus 7 to the 1/2 power. Okay? So it's pretty simple, really. let's do, now we're going to do greatest common factor, which you should have also had in Algebra 1. Let me see. Where the heck is my greatest common factor? Okay, so greatest common factor, you just pull out what the terms have in common. So if you have 25x squared plus x, what do these two terms have in common? X. You pull out the lowest power of the variable that they have in common. So they have in common x, you pull that out. So we have x times 25x plus 1. What we're doing is we're talking about different factoring techniques. Okay, so greatest common factor is a factoring technique. Difference of squares is a factoring technique. 36x cubed plus 6x squared. Why don't you do this one? You look at what 36 and 6 have in common, and then what do x cubed and x squared have in common, and that is what you pull out. And then what you have left is what remains. You should be able to take this and multiply through and get back to where you started. Some people think you'd have a 0 here if you pull out an x. You have a 1. I have to multiply that x through and get back to where I started. So what do 36 and 6 have in common? What factor? What's the greatest common factor? And then for x cubed and x squared, you look at what is the greatest common factor, which would be the lowest power on that exponent, and you pull that out. Right, so you pull out a 6 and an x, not 6 plus x, 6 times x. So you pull out 6, which is the factor between 36 and 6, and then you pull out x squared. The highest power between x squared and x cubed is x squared. So you're pulling out 6x squared. And then put in parentheses what you have left. You should be able to multiply it out so that you end up back where you started. Abigail, what do you have?
6x squared plus 6x plus 1.
Okay, good. Now notice when we pulled out the 6x squared, again, this did not leave a 0 there, it left 1. So I can multiply this back through. And I end up back with 36x cubed plus 6x squared. You can always check whether you did it right by checking if it comes out to that once you multiply it back. Okay? How about this one? 125y cubed z. So first look at your coefficients. What do 125, 25, and 5 have in common? Then look at your y's. See what is the highest power you can pull out. And then look at your z's and see what is the highest power you can pull out. And then you pull those out, multiply together. And then you put down what you have left. Is z. This is just a z, not a z cubed. Okay, so that's fine. Pull that out. What do you have left for each one? So go through each one, and you're going to have 3 terms there in parentheses. Okay, so 5. Okay, y is 4. Actually, y is the lowest power, and z is the lowest power. So what 525 and 125 have in common is 5. Then we pull out the lowest power. So z squared, z squared, z squared, we pull out a z. The lowest power y is y, so we're pulling out 5yz. And then what you have left, you should have 3 terms in parentheses. So you pull the 5 from the 125. 5 times what is it? Okay, so 125 divided by 5 is 25. Y cubed divided by y is y squared. Remember, we subtract those exponents when we divide. So x to the a over x to the b is x to the a minus b. What we're doing is we're dividing y cubed by y, so we subtract it, we get y squared. Z divided by z is just going to be 1. You know 25 divided by 5, so we get this. 5yz, 25y squared. 25 divided by 5 is 5. Y squared divided by y is y. Z squared divided by z is z. 5 divided by 5 is 1. Y divided by y is 1. Z squared divided by z is z. So when you divide them, you just subtract them. There's a 1 here, so 2 minus 1 gives us 1. Okay, 3 minus 1 gives us 2. All right? Let's do some others. (24x squared yz plus 2x y squared z squared). So look at what do 24 and 2 have in common? What's the factor? X squared and x, y squared and y, z and z squared. What's the factor for 24 and 2? 2. The lowest power between x squared and x is x. The lowest power between y and y squared is y. The lowest power between z and z squared is z. So you're pulling out 2x, y, z. And then you just look at what you have left. So 2x, y, z goes here. 24 divided by 2 is okay, so you pull out 2x, and we're going to add one more. Oh man, I forgot to add this. But we can keep going. Just add one more. See, what do you have left? It doesn't change anything in what you pull out. So just add one more term. So you have three terms in parentheses.
So notice that this x squared x is x, y, these cancel. And you go here, this cancels the x, y squared, and y is just y. Not that part.
Okay, so we get 2xyz times, in parentheses, 12x. The y and the z cancel. We divide 24 by 2, we get 12. We divide x squared by x, we get x. The y and the z cancel. In the next term, the x and the x cancels. The 2 cancels. All we have left is y and z. In the next term, all we have left is 2z squared. 4 divided by 2 is 2. The x and the y cancel. All we have is z cubed divided by z, which leaves us just z squared. Okay? Let's see you do this one. 3x squared y cubed plus 15xy to the fourth minus 21x cubed y squared. So you look at what 3, 15, and 21 have in common, what factor. And then x squared, x, and x cubed, you pull out the lowest power of x. Y squared, y cubed, y to the fourth, you pull out the lowest power of y.
Okay, now what do you have left in parentheses? So the first part, 15 is the factor we have in common. So put in it's the lowest power of x squared, x, and x cubed. Just x. It's the lowest power of y cubed, y to the fourth, y squared.
Okay. So we have here 3xy squared times xy plus 5y squared minus 7x squared. Okay, the lowest power of 3, 15, and 21 is 3. The lowest power of x squared, x. And x cubed is x. Lowest power of y was y squared. And this is what we have left. xy plus 5y squared minus 7x squared. Okay, so you just go through and divide 3 by 3, 15 by 3, 21 by 3. And then for all the others, you subtract those exponents. So y cubed divided by y squared gives us y. Okay. Here's an easy one. 2xy plus 4x. Kyla, what did you pull out? 2x. Okay. 2 and 4 have 2 in common. So we pull out 2x. Here's another one. Just go on to the next one. I'll go over the answers at the same time. 6wz plus 2wzt. 6wz plus 2, that's a w, z, zt. What do 6 and 2 have in common? W, W, Z, Z. It's so for the first one, you should have gotten 2x times y plus 2. We pulled out the 2x. That left us 2x and y plus 2. The second one, 6 and 2 have 2 for their common factor. W and W have W. Z and Z have Z. That leaves you 2WZ. So we get 2WZ times 3 plus T. Okay, we pulled out 2, the W, the Z. We have to be able to multiply this through to get back to where we started. All we had left was the constant 3, and then all we had left was the variable T. Do you understand? XY plus 4x plus 2xW. All you can pull out is that x. We don't have any other factor of 2 and other than 1 here. Y isn't in the middle term. W is only in one term. So all you can pull out is the x. That leaves you x times y plus 4 plus 2w. We'll do one last one. 6xy squared times y plus 3xy plus 9xy squared. So look at what 6, 3, and 9 have in common. Pull out your lowest powers of x, your lowest powers of y. So you're pulling out a 3. The lowest power of x is x. The lowest power of y is y. You're pulling out 3xy. And then just put what you have left after you pull it out. You pull out a 3, you're going to have a 2 here. Where did I put it? We pull out the 3, the x, all we have left is the x. Then we have just a 1 here. And then we have 3y. Okay? You got it? You can always multiply that through, see if you end up where you started. I forgot the 2. Should be a 2 there. Okay? All right. We're going to go on break and then come back into coursework. So that concludes the first video.